Dear student, Assalamu alaikum. Welcome once again to Chemistry Online class English version arranged by KPB School and College. Hope all of you are doing well. This is Irene Parveen. Today I would like to discuss about isotope, isobar, isotone and quantum number under chapter 2. At first, I would like to discuss about isotope. Now, what is isotope? Atoms of same elements which have same atomic number but different mass number are called isotopes to each other. That is, same atomic number same, but mass number different, and they are atoms of same element. For example, H11, that is hydrogen or protium, H21, this is deuterium, and this is tritium. These three are isotopes of hydrogen, and look here, the atomic number of these three atoms are same. You know, we can write atomic number as subscript with symbol. So here atomic number of hydrogen is 1, deuterium also 1 and tritium also 1. So atomic number same, but their mass number, look here, mass number of hydrogen is 1, but mass number of deuterium is 2 and mass number of tritium is 3. So their atomic number is equal but mass number different, so they are isotope to each other. Again, our next topic is isobar. Isobar, the atoms of the different elements. Isobar, the atoms of the different elements which have same mass number but different atomic number are called isobar to each other. That means mass number, here mass number same, but atomic number different. For example, tellurium and iodine. These two are isobar to each other because look here, their mass number is same. The mass number of tellurium is 127 and mass number of iodine is also 127, but their atomic number is different. The atomic number of tellurium is 53 and atomic number of iodine is 52. So they are isobar to each other. Now our next topic is isotone. The atoms of different element which have same number of neutrons but different atomic number are called isotone to each other. That is, Newton number same, but atomic number different. For example, carbon 14 and oxygen 16. Look at the symbol please. Here the Newton number of carbon 14 is 14 minus 6, that is 8, and Newton number of oxygen is 16 minus 8, that is 8. So their Newton number are same, but their atomic number, you can know, we can write atomic number as subscript with symbol. Atomic number of carbon is 6 and atomic number of oxygen is different. So carbon 14 and oxygen 16 are isotone to each other. Now our next topic is quantum number. Now our next topic is quantum number. You know, around the nucleus there are different number of energy levels, and the electrons are revolved in this energy level by following some rules. Electron not only revolves around the nucleus, but also they spin around their own axis. To know the energy level, size, shape and direction where electrons can be revolved in an atom, the some numbers is necessary. These numbers are called quantum numbers. There are 4 quantum numbers, and these are principal quantum number, subsidiary quantum number, magnetic quantum number and spin quantum number. Now I would like to discuss about principal quantum number. The number which express the principal energy level in which electrons can revolve and represents the average distance of the electrons from the nucleus, and also represents the size of the electron orbit, is called principal quantum number. It is expressed by n. This principal number is expressed by n, where n equal to 1, 2, 3, etc. When n equal to 1, it represents the first energy level, or K shell. The name of first energy level is K shell. When n equal to 2, it represents second energy level, or L shell. And when n equal to 3, it represents third energy level, or M shell. And when n equal to 4, it represents fourth energy level or N shell, and so on. And the most important thing is that every energy level has certain amount of energy, and this energy can increase as the value of N increases. Now I would like to discuss about subsidiary quantum number. Subsidiary quantum number. In principal energy levels, there are some sub-levels. That means principal quantum principal energy levels can be further divided into few sub-levels, and we can identify the number of sub-levels by the value of subsidiary quantum number. Now, the quantum number which express the shape of the electron orbit is called subsidiary quantum number, and it is denoted by L, and the value of L is 0 to n minus 1. That is, if n equal to 1, then value of n equal to 0 to n minus 1, that means 0, that is 0. It represents first energy shell has only one sub shell or sub energy level, and it is represented by 1s, and when n equal to 2, the value of L is 0, 1, that means 2 value. So second energy level has two subshells, which is represented by 2s and 2p, and when n equal to 3, the value of L is 0, 1, 2, that is third energy level has 3 subshell, and these are represented by 3s, 3p and 3d, and when n equal to 4, the value of L is 0, 1, 2 and 3, that is fourth energy level has 4 subshells, and it is represented by 4s, 4p, 4d and 4f. Usually, a principal energy level has maximum 4 subshells. Look at the table, please. Value of L and name of subshells. When value of L is 0, then the name of subshell is S, and the source of the name is sharp. And when the value of L is 1, then the name of subshell is P, and this comes from principal. And when the value of L is 2, the name of subshell is D, which comes from diffuse. And when the value of L is 3, then the name of subshell is F, which comes from fundamental. Now I would like to discuss about magnetic quantum number. You know, in the center of an atom there are positively charged nucleus, and around this nucleus there are negatively charged neutrons. As a result, an electric field is created, and due to this electric field, a magnetic field is also created. And due to the effect of this magnetic field, some orientation or different three-dimensional arrangement may occur. So, the quantum number which express the orientation or different three-dimensional structure of electron orbit are called magnetic quantum numbers, and it is expressed by m. M for magnetic quantum number, and the value of m depends on the value of L, which is value of m, which is plus minus L, that is plus L to minus L including 0. When n equal to 1, then n equal to 0 and m equal to also 0, and when n equal to 2, then L equal to 0, 1, and L equal to plus 1, minus 1, plus 2, minus 2, and also 0. Now, magnetic quantum number, you know, it is expressed by m, and look at the chart please. Orbitals of different sublevels. From magnetic quantum number, we can identify the number of different sublevels or number of different orbitals. When principal quantum number is 1, then subsidiary quantum number L equal to 0. Then the name of sublevel is 1s, and the magnetic quantum number is 0, that is 1 value. That's why orbital number is also 1. And when n equal to 2, then we get 2 value of L, and sublevel name is 2s and 2p. For 2s, we get only one value for m, that is orbital number 1, and for 2p, we get 3 values of m, and the orbital number is 3. Now, when n equal to 3, then we get 3 value of L, 0, 1, 2, and for 0 the subshell is 3s, for 1 subshell is 3p, and for 2 subshell is 3d, and then the value of m is for s shell, s subshell, the value of m is 0, so orbital number 1, and for p shell the value of m is plus 1, 0 and minus, that is 3 value, so the orbital number is also 3. And for d subshell, the value of m is 5 value. We get 5 value for m, that's why the orbital number is 5, and for n for 4, the value of L is 0, 1, 2, 3, and the name of sub level 4S, 4P, 4T, 4F, and the value of M is 0 for S subshell, and the value we get 3 value for P subshell, so orbital number is 3, and for D subshell we get 5 value of M, that is orbital number 5, and for F subshell we get 7 value for M, that is orbital number is 7. That's why we can identify orbital numbers from the magnetic quantum number. Now our next topic is spin quantum number. Now I would like to discuss about spin quantum number. You know, electron spins about its own axis to the direction of the clock, that is clockwise, or in opposite direction to the clock, that is anti-clockwise. So the number which expresses the spin of electron is called spin quantum number, and it is expressed by S, and S has two values, and these are plus half and minus half. You know, electron moves around the nucleus. This is electron. This electron moves around the nucleus. And electron also moves around its own axis. This electron moves clockwise, and this electron moves anti-clockwise. When electron moves clockwise, then its value is plus 2, and when electron moves anti-clockwise, then its value is minus 2. Now we can summarize the 4 quantum number. Name of quantum number: principal quantum number, which is denoted by N, and by this we can determine the size of the orbit and also gives a measure of the energy. And secondly, subsidiary quantum number, which is denoted by L, and by which we can determine the shape of the orbit and indicates whether that orbit is circular or elliptical. And number 3, magnetic quantum number, which is denoted by M, and by which we can determine the number of possible orientations in space or the number of planes in which the orbitals are situated. And lastly, spin quantum number, which is denoted by S, and by which we can determine the spin directions. Hope this class is helpful for you. No more today. Thank you everybody. Bye.